I'm glad that everybody's here. I'm excited to have this conversation. I love seeing this community and seeing how we have grown over the years, and I feel like there are new hurdles that we weren't looking at 5 years ago in process and in business and in networking and everything. So it's an exciting time, and my focus is in process. That's what lights me up. Is after the oil's collected, how do we turn it into biodiesel or whatever we need to turn it into? Focusing on biodiesel today, in a way that generates the most income for the least amount of expenditure, or just the most profit, to make the best of the oil that we work hard to collect. So a little introduction to myself. My name is Shumaker. I've been in the biodiesel industry for going on 6 years. Before that, I was doing research in biodiesel, sort of second generation catalysis at the University of Kentucky. And after I got my engineering degree, I went into the industry and I worked in the North Carolina, South Carolina, Virginia, Kentucky area for the last 6 years, mostly in production. So, first thing I want to bring up is an opinion that I've come to over the years of working in the biodiesel industry, especially the community scale biodiesel industry, and how important safety and quality are for the strength of our collective, of all the individual businesses that come up to work towards a largely shared vision. I think everybody's got a little bit different version of that vision, but there's a lot of overlap. And so what I've seen is that institutional safety is not always understood or approached with a respect that I think it deserves if we're going to be handling methanol, if we're going to be handling catalyst, if we're going to be working with high temperatures, high pressures, that kind of thing, or slippery grounds, or for hot days on end, or driving trucks that are half full of liquid so it's sloshing around the back, or whatever the case may be. So I personally feel like as we grow in process, as we grow in business, being mindful about growing in safety is an important piece of the puzzle to move forward, and it also helps us have stronger credibility in bigger circles. To have a voice, and they can say, oh, well, you know, you're making 100,000 gallons per year, or you're making however many gallons, and you're not even getting the safety part right, or you're not making quality fuel. And if you can say, well, actually, you know, I am, then there's a credibility thing there that we can continue standing with good character and continue with the message that we have, which I think that the bigger voices that may want to discredit us, they don't have something that we have in terms of community and vision. So for that to be discredited based on institutional safety or poor fuel quality is a bad way to go out. So I want to see fuel quality and safety growing with our process and with our evolution as a sector in the biodiesel industry. I also want to hold out that if anybody wants to have conversation during this talk, that's really my vision, is not for me to just tell you what I think, but I definitely want to hear from the group, because we all have something to contribute, and I've got a piece and everybody out there in the audience has a piece, and I want us all to bring that together, and that's part of our strength, is sharing that information, sharing that perspective. So I just want to go over these reactions. I know that we've all seen probably all of these reactions 100 times or more, and I still wonder if, as a community, we completely understand that we're basically dealing with, in this chemistry here, we're dealing with an FFA chain that comes over to a carbon and an oxygen, and most of what we're doing is just what happens here. Is that a glycerin chain with more of these happening? Is that a biodiesel chain? Is it a soap, or is it a free fatty acid? And you can go, and I guess I should also put glycerin up there. That would be the monos, dyes, and triglycerides. And so most of what we're doing is just changing that one little piece, and this is, a long chain, and understanding that we can go between free fatty acid and soap, and between soap and free fatty acid, and between free fatty acid and biodiesel. That's esterification. And then, of course, what we're trying to do is go from triglycerides to the fatty acid methyl esters with making as little of this as we can and having this get in the way as little as possible. So it's just, I think, worth mentioning and putting these equations up to make sure that stays clear when you're trying to figure out a process and you got 10 different variables you're working with, and you're not sure if it's something going on in your pump, or if it's the temperature of your process, or if your whole tank is the same temperature as what your thermometer says, or why isn't this separating right, or what's going on. Maintaining a firm grounding in the basics of what we're trying to do is not always as easy to remember when you're looking at the equations right now as when you're on hour 10 with a greasy wrench in your hand and you want that load to go out the next day. Or you're designing a process or trying to decide which direction you want to grow your plant. So maintaining that grounding as we move forward and develop the next generation of biodiesel plants is something that I think is important, because as we grow in sophistication, more equations are going to go up here, and we don't want to be unclear about the basics that we've all been doing or maybe are looking at doing, and this is something that I think is worth continuing to deepen our understanding of. And I really enjoyed watching Dr. Van Gerpen's talk last year, who was really going into some of the nitty-gritty about what's going on here and what happens when this water piece, which doesn't show up a lot in this. I mean, it gets formed from the potassium, and when you're turning the free fatty acids into soap, and it gets formed when you're mixing the catalyst with the methanol. But what happens in a reaction that gets out of control and either doesn't separate or doesn't wash well is in trying to do this, and you know that some of this is going to happen where you're getting rid of your FFAs by adding extra catalyst. This is assuming waste vegetable oil, maybe 3, 4, 5% FFA. Well, when this reaction happens, that happens, and the more that happens, the more that this little AQ matters, and so it starts to feed itself, and then you start tapping into your triglycerides too, instead of just your FFAs, and you get more soap, which is an emulsifier. So you get what that looks like after you're draining your glycerin. It looks like more glycerin, but you're draining yield. So just being aware of how that's happening, I think is important just to keep in mind. And I think that a lot of us have probably learned this long enough ago that there's a potential to forget it, or to forget the importance during the actual processing. That's been my experience. So getting back to that is something that I try to keep in mind all the way through. And then with acid esterification, you've got, what we're trying to do is turn the free fatty acids into, basically turn the free fatty acids into methyl esters. And in the process, we're gonna, any soap that may be in the oil already, which there is a little bit, typically, at least from what I've seen, you're going to create FFAs that can also be turned into free fatty acids. So not only are the FFAs going to contribute to yield, but the soap will contribute as well. And maybe to a lesser extent, you'll have, since this is a divalent acid, you might have, I want to mention that this is consuming your catalyst though, and so you need to compensate for that in working out the math to set up a good recipe, and it may get further consumed or not. And then of course there's a little bit of of acid catalyzed transesterification that goes on. So I think that, as you know, I've said it, I think these are important things to keep in mind. And so, yes, great.
This has been a while. KHSO4?
So KHSO4 is when the sulfuric acid will pull one of these potassiums off of the soap, and the soap will turn into a fatty acid because this H goes there. So basically this H has gone and turned that soap into a free fatty acid. And what it leaves behind is this complex here. And so that is, and
Is that soapy sulfuric acid, or what is it?
you could say that. I don't know if a chemist would say that, but in biodiesel talk, we could say that's a soapy sulfuric acid, maybe. It's not a soap. It's so it's a polyatomic ion with two different types of protons, and it is less reactive than the sulfuric acid. So to what extent this reaction happens is questionable, and it may be that all of your soap is just knocking off one hydrogen from your acid, and it's no longer going to be a catalyst, but it's also not going to contribute to getting rid of your soap. So it may be a 1-to-1 ratio that this equation doesn't happen, and you're losing more acid per soap, and you're basically gaining this unuseful chemical that will be in the mix. Here's John.
Why is it only one potassium? Why doesn't it go to K2SO4?
It would be based on equilibrium. So it might or it might not, but it's going to be less likely to do this than it is to do this. This is definitely going to happen.
But is that a typo? You have K2HSO4.
I'm sorry, it is a typo. There shouldn't be an H there. That was your question?
Yeah, I was
Okay,
just wondering
thank you.
why it doesn't all of it go to that.
Why it doesn't all go to this, but
Yeah.
minus the H. Okay, so it is. It might. It's possible that it does, but you really get into something more complicated there, where you have to look at the equilibrium of
Right.
what's going on, because it's less reactive. Okay, so in general, putting those reactions to work, this has been my experience with what happens in the biodiesel process. And I'd love to hear alternative perspectives on this, or if someone has another truth that is different than this, because having this conversation, I think, is important. And I think that it's important to remember that we can't start talking about what's going on down here without understanding what's going on up here, and that's going to change from process to process. So it's an incomplete conversation just to talk about washing unless you assume some basis up here, because it's going to turn out very different down here. So in oil preparation, a typical assumption that I've made in the past that I found to hold fairly true with lots of different gallons of WVO is that it's coming out of the restaurant between 15 and 20% water and food chunks, called schmutz, and 2 to 10% FFA. Does that seem like a reasonable assumption? Do people have different experiences?
30.
What's that?
30%.
30% food and water?
Yeah.
That's what you see? So some more, anybody less?
We average 11%.
11%?
Yeah, I was just gonna say 10 to 20%.
10 to 20, and Jeff?
We were up at 15-20%, and just through education of our vendors and frequency of pickup, we've knocked that down to single digits.
Great, great. Well, that's a nice tip. Yeah, to really put energy into the customer relationship with the.
It does work. You don't think it is when you're out there collecting sometimes, but it does work.
Great. Did somebody? Yes.
My area is about 40-45% regularly.
Food and water,
Yeah.
40 to 45%. Yeah. Okay. So you have more in your stream.
Can I ask a general question there? What do people do with their slips?
Great question.
What?
What do people do with it? I mean, if it's 10, 15, 20%, that's just straight loss out of your source. What do people do with that?
First of all, you don't pay your client for that, you deduct the water from what you pay your client. So it's not lost in that sense. You decant it off, you let it settle out, you dispose of the
Okay.
bottom layer will be clear water you get rid of.
Dispose. Okay, so water you just down the drain.
I mean, if you've got very clear separation water on the bottom, then you got a layer you got to truck to a compost facility or something.
Okay, so
We've got another
that's
rendering
one
on
approach.
that.
Kumar, what do you do?
So we collect directly from restaurants, so you can't, you can say that you're only paying for the oil portion, but when you have hundreds and hundreds of restaurants, that's kind of hard to actually back up. So what you do is you try to encourage good behavior, and then what we do with the food solids is we press the oil out of it as much as we can, and then we send the food solids to a compost company. And with the water, we mix the water waste with the rest of the water waste in our process, and we mix that with glycerin waste, and we bring that to a methane digester that our local utility district has.
So when you say the food that you take to composter, you're selling to a composter, you're taking to a composter, or you're paying a composter to take
We're
away?
paying them. Yeah, I mean, ideally you could sell it, but the problem is the oil level is high enough that it's not really an ideal compost stock.
Right.
And I would say if you're getting upwards of 40–45% moisture schmutz in your oil, the restaurant's probably washing their fryer.
They are.
Dumping that water into your bin. And you might be able to educate them to not do that.
Yeah, that's a cheap and easy way to make your life easier.
Great, so it sounds like there's some consensus in the room about really educating the restaurants about what we're looking for. Yeah, at this table, I think.
I was gonna say that we set up a relationship with another renderer, and they drop out a container out in front of our place, and they're paying us 5 to 7 cents a pound.
Great, so you're selling it just raw after you separate it. You
Yeah,
just
it's
put it
great
in
for
a
us,
container.
we used to have the storage problems, just piling up everywhere, and now we just take it back in a bucket and throw it in.
And how much of that's water though, and that's just sample food part?
That's maybe 10% water.
Where you do the water?
Just throw it in.
So you've just taken the good cut and dumped as much to someone farther down the chain who's using it for a lower value end product like
We thought it was gonna be
Alpha.
lower volume, and then what we found out was that they actually turn the brown grease into biodiesel and they sell the yellow grease to animals. Which I was actually very surprised to hear. That's what we were doing.
There's some stuff, that's good. There's a local compost place that I'm lucky, they'll take the glycerin, they'll take the food waste. You would also contact the local water treatment places and see how much they'll actually allow you to put down a drain. But I would recommend calling first. But one of the things I've been researching and I can't wait to do myself is a biogas digester. And then I can recover that methane and recycle that to heat stuff up, warehouse, whatever.
So integrate your system, have another value stream. Great. John?
Kumar, you guys, do you have to deal with hazardous, like hazmat, with hauling and glycerin and ethanol currently?
Since we dilute it down so much with the water, it's actually below the point where we would have to do that.
Okay, yeah, I was gonna say, because I remember there was a producer here in Colorado, they started doing that, I think, and that allowed them to haul the glycerin truck, just the straight glycerin waste with too much methanol in it.
Yeah, it's actually, I hate the phrase kill two birds with one stone, so let's say it feeds two birds with one seed.
Any other comments on dealing with schmutz and yes?
So we're working with Loyola University and they're setting up a new system for their water wash. They got an EPA grant to look at taking the water wash and sending it to a constructed wetland. And so inside of the routing system of these different types of plants, they absorb nutrients. And so I don't know how that research is going to turn out, but they think it's going to clean up that water to the point where when it comes out, it's clean enough just to run down the drain.
So biotreating the water and feeding what's in the water to something else that might also be a value stream or a beautiful garden or something. Great, that's a neat idea. Again, to sort of go back to the box that I draw, which is trying to process the oil, I'm mostly interested in getting the water and the schmutz out. And once it's out, I put it in a tank somewhere, and typically somebody else deals with it. And so I like hearing all those ideas. And when I'm trying to separate, what I want is a really good separation where there's not a whole lot of oil going out with the schmutz. And so seeing that happen at between 165 and 185 Fahrenheit is what I found to be a good temperature that I think is probably harsh on anything that is trying to grow in that oil already, because it's already been sitting in the presence of water and food in a bin for maybe a week or longer. So heating it up to a good hot temperature, I think it's worth it to kind of stabilize the situation biologically in the oil. I know that it is possible to do it at lower temperatures, and maybe you're having a lot of success with that. And, does anybody have thoughts on that? It's certainly cheaper not to heat it up as much. Great.
Well, I've got a producer, he's here, he's just not in this presentation, but he really did all sorts of testing with different temperatures, hotter than this, cooler than this, and you've hit the magic button on his. He says he can take thousands of gallons, put it in a big tank, heat it to 165, that's about his magic number. He just leaves it there, and he'll come back the next morning, all the water settled to the bottom, all the schmutz is settled to the bottom. He says the oil actually gets this clear look to it, and that's coming in from restaurants with just that amount of, so he's not having to boil it or anything, he just takes it to 165. So that's neat to see that you hit the same thing.
Great, yeah, that's good. That's exactly the cross-referencing that I want to see. I'm glad to hear that. Kumar, did you have something?
You know what he said, we try and hit 160, sometimes we're as low as 120.
Great.
And duration?
Duration for settling, I think overnight. Maybe anybody faster than overnight? Say 10 hours?
So that's get to 165 and then let it go naturally cool from there.
No,
Maintain
hold it
it.
at that without.
Hold it at 165
without
overnight.
Maintain temperature.
Yeah, I would bring it to temperature and then let it hang out there for 10 hours. And I just want to say, I really think having an insulated tank is worth it. Just go ahead and bite the bullet and put the insulation in. I think it's going to it'll start paying itself back that much faster.
What are you using for insulation? Closed cell foam or?
I don't have a real strong opinion on that. I've seen the spray foam work really well. I've done some systems where it's just straight up fiberglass bats covered with the reflective insulation. That's a little, it's easier and quicker than the foam stuff, but it also, once the oil hits it, which invariably it does, I don't know if it even works much anymore after that. So it's worth doing, but I think that if you want to do it right, foam's probably the way to go. Yes, sir.
I own an insulation company, so you do that closed cell foam, it's explosive. So if it catches fire, so if your fire chief will allow it, you can have a fire retardant put it in closed cell foam, and it can spray your tanks, but it'll still ignite. If it gets a flame on it, it'll combust very quickly.
Fire hazard.
So that's why a lot of them have to use, there's a special actually fiberglass bats you can buy. So if you go to a bigger insulation company, you can special order specific fiberglass insulation that's made for tanks. And so it can take chemical on it, it can take spills on it. It's pretty heavy duty, it's expensive, but it'll last the life of the tank.
Very cool. Even if it gets oil on it, it'll survive.
It just doesn't absorb, it kind of has a rubbery texture on the outside of it. As long as you seal it to the tank, then anything that splashes on the tank won't get into the insulation.
As an insulation professional, would that be your insulation
I do
choice?
it. Closed cell foam's the easiest way. I don't give you guys grief at all for doing that. It's
There's
really
no way
good
to make it
insulation.
non.
You can put a fire retardant in it, but it's still, it's just it's still a pretty high fire hazard, but I don't know, it's debatable, when are you gonna have open flames right up against your tank too, so I don't know, it's a debate at that point. It's definitely gonna be cheaper though, to do closed cell foam.
Great. Yes, sir.
There's been some paint companies that came out with a two-part epoxy coating. I've seen some biodiesel producers put on their tanks. It's supposed to be equal to 2 inches of insulation. And you can just spray it on. You have to spray it on, I think it's almost 9 mils thick. But it's a two-part paint coating. I think it might be Sherwin-Williams, but don't hold me to that.
Okay, that's neat. That's a neat tip. That looks like it was look good and offer a nice installation. You have any idea what it costs?
Cheaper than putting on fiberglass and metal over it.
Cool.
'Cause they went that route.
Okay. So a couple of systems that I've seen that have worked well with separating the water and schmutz is if you have a good cone bottom tank without a lip right there, if you can either heat it with a jacket or with a coil down in there, that's a good way to heat it. I'm not a big fan of electrical heat. If you can get away from it, if you can get a boiler type heat loop going, I think that's better. And larger pipe, which is on the outside, which would send the schmutz out. I'm not sure if I can give a clear explanation of that. I don't know if that's a lot to digest right now. I just learned about it, but Eric has it backwards and forwards, so that's a neat new one that I just heard about yesterday. So if you want to get the moisture down in your oil, you got to get all the food particles out, and that can be done with or without filtration. But filtration gives you a little leeway on your separation process. After you've gotten the schmutz out, if you recirculate it while it's hot, and I would even reapply heat to it, pulling it out of the bottom of that tank and just dropping it back into the top overnight or for however many hours works for your process. It's going to vary on how you need to have the tank open or to have some sort of negative pressure pulling the headspace out. But you can do it passively, just open the manway, recirculate that oil, and it's just free falling. You can put a splash plate, but it works fine, just free falling. And you can get your moisture down, to a tenth of what it might settle to. If it settles to, say, 5,000 ppm or 0.5%, you can get it down another to a tenth of that by recirculating. And depending on how well you set up that system will depend on how long it'll take to do that. Yes, sir.
Do you have to worry about raising the FFA since you're heating it more?
I've never worried about that, and I haven't done very specific tests on it, but I've never seen it be a problem. Has anybody definitely documented or seen using tests that they are increasing the FFA in their oil by heating it for an extra day?
Yes.
You have?
So to mitigate that, we put an antioxidant in collection containers at the restaurant. We go pump a restaurant and then we leave an empty container with an antioxidant.
Like Santaquin or something?
And we use twice the labeled dosage on Santaquin at the restaurant, and then we come in and put another twice the labeled dosage in our heat settling tank. And that counteracts the effect.
Okay. Great. What kind of increase were you seeing if you say heated it and recirculated it?
Well, and I can't, this was early on, I don't know how, we were probably getting some sitting on the yard and some in the heat process tank as well, but it would probably come in at 10% and we would end up processing it, it would be in the high teens.
Okay.
So a measurable effect.
Yeah,
And so now we're stabilizing at about 9 or 10% is what we're processing, 8 to 10%.
Okay. Okay, so it could be that happens with higher FFA. I've been looking more at 3% stuff, 5% stuff. Haven't seen a big increase, so maybe the FFA level affects it. I don't know.
I'd probably agree with that,
Yeah?
because I don't see a big change in our process in the heating and filtering of the oil.
Mm-hmm. Okay,
And it's all low FFA, under 4%.
Yeah. Great. John?
What about other types of oxidation? Are you a way to measure that, or is that something increased by circulating? You're just like circulating through air?
You're pulling it out of the bottom of the tank and putting it back in the top of the tank, and then just letting it fall from the top of the tank. So
Okay, yeah.
you just go into a bone on the top,
Right.
and it's so it just spreads out, and that gives some surface area and lets it evaporate.
Right. Yeah, so you're definitely increasing exposure to air. By
Yeah.
doing that. So like,
Decreasing your oxidability.
yeah. So would you have
Could be.
concerns with that, or?
I haven't seen it in experience. I've seen it not be an issue.
We actually bubble ours.
Yeah.
We just run bubblers. at a certain point, depending on what we see after the first 5 or 6 hours. I mean, some oil we can be done in 8 hours, and other oil, you know, it's going to go 24 hours. It depends. So if we need to speed up the moisture process, kind of like what he's doing here, we'll bubble it.
And you don't have like problems like varnish or anything forming.
Have them.
Yes, sir.
So we were using a headspace desiccation on grease on the front end and on fuel on the back end. And we were bumping up against, we weren't flowing, but we were bumping right up against on-stage stability numbers. So we've switched to a vacuum assisted drying on the front end and back end. Because the theory is less oxygen exposure.
Yeah.
That's kind of what I expected to see happen.
Okay, so you added a vacuum pump to the mix and had better luck with it. So that more complexity and got a better result. Great. So I have definitely seen the recirculation just dropping into the top not give oxidative stability issues on the back end. So it could go back to the FFA of the original feedstock and how ready it is already to degrade and how much the peroxide has gone up in the hole as the oxidation process starts. Yeah. I do want to mention that I'm definitely not going to get through all these slides, and there's a lot of information on these slides that I wanted to include for a reference. So it'll be available either through CBC or you can get in touch with me. So I'm interested in what parts of this process people are most interested in talking about for the rest of the, we have 20 minutes, and I would say that there's still a good deal of information yet that we haven't touched on. So what are people most interested in? And we can maybe just skip around, and because I think this is a good conversation, that hearing from all different perspectives in real life, from real experiences. Anybody want to point to a particular spot?
Green.
Green, separations and purifications, love it. Let's see. So in your biodiesel, the reaction is complete, and you're in spec for your completion of conversion, and you are now dealing with the biodiesel, which is the stuff that you want, and below it is the glycerin, and in the glycerin, of course, is probably most of all of these things. And then in the biodiesel, there's also soap. There's probably a little bit, probably less methoxide, but there's probably some methanol where it's actually separated out and dissolved in the biodiesel. And then maybe a little bit of moisture, which will be more of a problem if you water wash later, but at this point it's not there, so or it's a small amount. And then residual monos and dyes, which are probably in the glycerin layer. So that's the solution we're dealing with. You stop the pump, it settles out. Some amount of this stuff settles to the bottom with that, and some amount of it stays up in the biodiesel. And you can start out with the sort of the basic that I would call like the first generation. What I started on in 2007 was, so after the reactor, you drain out the glycerin using gravity, you send the biodiesel over, mist wash it, and then after you've washed it down to a comfortable place with your soap number, maybe less than 30 ppm soap, you dry it with air, and then you'd send it to fuel holding, where you'd also add your additive, your ethanox or some kind of stabilizer. So that's the where I started, and I think that's where maybe a lot of us started. Anybody work with a process like that? Just straight up water washing after you do the reaction. So moving to sort of the next level, you do a little bit of water washing and then some drying. You don't have to do as much water washing, and you run through a dry wash. You go through an ion exchange resin or an EcoTune Pure or like a wood chip type tank, and then resin or a filter press. Caleb.
What level do you try to get your soap ppm down to if you're going to do a dry wash afterwards?
I go for 500 ppm. Other people, opinions?
I used to do 800.
800. What soap level do you go down to before you send it through your resin?
Depends where it's going. We've done a cellulose tower followed by an ion exchange tower. And the cellulose tower is good like the sledgehammer, and the ion tower is good like a real fine little tool. Pick your analogy there. But you can take large chunks of soap out with the cellulose. So you can go from 1,000 down to 200, and you can go from 200 down to 50 with the ions.
Great, great.
You know, Rod last year gave some recommendations. If you're above 2,500 ppm, you don't want to put it into the ion exchange at all. You want to go into some sort of a cellulose media and knock it down. And my goal is under 1,000 before I go into resin.
Going into resin. And you're happy with your resin life with that? It doesn't feel like it goes out too fast, or?
Well, I sell resin, so that's a. I think the lower. I'm curious to know what others.
Yeah, so we got an 800, 500, others. Soap ppm going into resin. So it sounds like we're at 500 to 1,000 ranges.
I've gone really high with it, but I couldn't even tell you what it was, but it is very, very high. And I mean, the resin's how resin. Resins do the job.
Yeah. The question is, how long will it last? I think, and how much acid does it add? Yes, sir.
We noticed a big change in our resin columns on your flow rate. We adjust the flow rate of how much fuel we're flowing through. We could greatly increase our resin life before we have to methanol wash it.
Interesting.
Just by slowing down. So we went from columns that were pretty skinny to they're about 25 feet tall and about 5 feet around.
Yeah.
And so it goes through us so slow that our resin seems to last a lot longer.
For a column like that, do you have a feel of what your flow rate is when you say slow?
We're running it through there at 7 gallons a minute per column.
Uh-huh.
So it goes through 2 columns at a time, so it goes through at least 700-800 gallons of resin. And with us, we can't really do Eco 2 Pure because we don't have a good way to dispose of it.
Yeah.
So we maybe do that on thing because you have the issues with spontaneous combustion and all that stuff.
Yeah, big issue.
So we just do the dry wash in it. It works really well so far.
Great.
The fun co-product recommendation: take your cellulose dry wash material that you've got out, it's soaked in fuel, just shove it in a toilet paper tube and call it fire starter log. Your burns really clear, they last about 45 minutes, you can give them away at Earth Day events, you can sell them for $1, whatever, we call it a biofire log. But it's a waste product that you can't dispose of in any other kind of way until you turn it into a
I
co-product.
think that's a really
And all you do is just
neat idea. The concern I have with that is if you hand those out and people take them home and they put them in their garage, that's really in process control. You include a methanol recovery unit on there, so now you're not washing out as much of the methanol, which makes your wastewater stream less of a concern. You're also getting a lot of this methanol back, which is a nice recycle stream, and you're buying a chiller, and you're really needing to look at how much heat you had in the first place in terms of a boiler, or do you have enough for methanol recovery? It's a pretty energy intensive type operation. And this model here would be coarse flash. So it's a lot easier to come up with a coarse flash drum that will get you most of the value in this stream here, but you're still not going to be in spec for flash point. And so you need to follow that up with some kind of a water wash, or you might just bubble it to get the methanol out. You can bubble it down into flash point, into spec for flash point. Again, you're getting into that issue of how much air you want to be bubbling through the liquid. But you do get this is kind of, you get this value stream out, and you don't necessarily simplify your wash process much, but you do have a few different options here rather than just having to hit it with water. And then this is moving into a water-free system, another step up in complexity. Set up a flash drum that actually gets you down to 2,000 ppm or less of methanol in your biodiesel. And at that point, you can get rid of the soap not by washing it out, but just by settling it out. And it's not real fun to deal with the soap, but it's not fun to deal with water in your fuel either. So it's a different approach that might save you on a waste stream. Caleb?
Will that work with sodium or potassium, or just sodium?
Works with, let's see, the soap settling, sodium or potassium. I've seen it in both, and it's not fun to deal with it either. It's
not fun as in hard to get the soap out, or?
Well, so here's what happened. You put it into, you take it to the soap settling tank, and let's say that's a cone bottom tank. And so you get this great settle, and you've got this clear bio on top, and you've got this nicely settled majority of your soap down in the bottom of your settling tank, and then you go to drain it out, and nothing happens when you open the valve. Or it starts flowing, and these chunks go out, and you're like, yeah, I'm getting rid of this soap, this is great. But then the fuel clears up, but there's chunks just all over the inside of the tank, and you're draining out a lot of the fuel for an occasional chunk of soap coming out. If you try to pump it, it will clog up your pump. If you try to add water to it, it will become very thick, and I've even seen like vac trucks not be able to suck it because it has turned into this very thick, stable emulsion, or even like a solid at that point. And that's with potassium, you know, it's solidified, so it'd be worse with sodium. So yeah, it's not fun. So what Kelly Green and I have been working on is instead of trying to drain the soap, which has been a royal headache for every plant I've seen it try to be done with the draining, stick a pipe down in the top that you can adjust, and have a sight tube on the top of that pipe, and you can slide it down in that tank, pulling out clean fuel until you hit that soapy layer, and then you go back up, and in the case of Kelly Green, you tighten up your hose clamp, and it's locked in place, and then you're pulling out fuel that's maybe 700 to 500 ppm soap, and you've got this settled soap in the bottom. And you can get the treasured fuel out, and then you can deal with the soap. And you can drain it out, or you can vacuum it out. Is a great way to deal with it that way. As long as you don't add water, it will still flow under vacuum. So that's sort of the edge that we're working on right now. Is no water wash. Have your flash point inspect by the time you go to soap settling. Actually, the flash point does go down just a little bit when the soap settles. It goes up, meaning the methanol content in the fuel goes down. So you get about 5 to 10 degrees Celsius increase in flash point just by letting the soap settle out. So there's a little flexibility, but you still want to get the flash point to 110 or 120 degrees Celsius coming out of this flash drum. And that's a little more challenging than just getting most of the value stream out, because you can get most of the 95% of the value stream out, and you still have 50 degrees to go on your flash point, so that you're really not getting a lot of value in terms of recycled methanol when you're getting your flash point into spec there, but you are significantly changing what happens downstream. So at the point of being at 700 or 500 ppm soap coming out of there, you can go right through the dry wash, or you can move into a centrifuge process, and you can get it down even lower. In theory, you could have more settling tanks and let it settle longer, and maybe get it down to the 200 range. And if you're down in the 200 range, that's below where you even need to be for your dry wash if you're doing a resin type system. So you're in a pretty good place for that. And yeah, okay, so we've got, we want to cut it at this time or in 10 minutes?
Oh, give a little buffer, if you've got a couple questions, any last things.
Okay, great. So that's kind of where I've gotten to with what I am, the edge that I've been working on, and hope that somebody, anybody else finds that interesting and want to move their process in that direction. It's a good way to go. Yes, sir.
I was wondering where biodiesel distillation fits in.
Biodiesel distillation fits in Scheme 5, which is not on here. That's I would say that's maybe the next step, and I think that you need to be in multi-million gallon per year plants before that to make sense. And I don't know that. Maybe small scale, there is a place for distillation in small scale. And if that's true and anybody knows about it, I'd love to hear about that. But I think of distillation as something that is more complexity. If this is difficult to achieve, the fine-tuned into spec flash process, the distillation is going to be another level of difficulty. So that's where it fits in. And I included on the slide, this is a kind of a general P&ID that I put together of a flash process. I didn't get flow rates in there, and you got a little bit of temperatures and pressures, but if somebody wants to dig into it, this would be a nice little reference to get some ideas. But with this system, even the liquid ring pump is kind of complicated, and you've got a chiller, and you've got to have the heat available. So it's kind of, I think that's part of where we are in our growing edge, is getting our methanol recovery, getting us in spec with Flashpoint, if we want to get away from water washing. And then, so I just put this in here as the importance of having a holding tank before you go to the final fuel tank. If you can, have a place where you can do all your quality testing before it's mixed with the fuel that you're wanting to ship out. So you can always have fuel on hand that you're wanting to ship out, and more fuel is being accumulated, that after it passes the tests, it can move into that area. I do want to skip to an opinion that I've come to after working in maybe 6 or 7 commercial facilities, and really just focusing on these process issues over the years, is that our safety, our commitment to quality, and our deepening our understanding of the process are tools that we need to hone to continue our viability in a challenging market. And the collaboration that happens at this conference and outside this conference, I think, is a huge, valuable asset that we can leverage that helps us grow faster than maybe some more competitive type approaches where everyone's holding their information close to their chest. I have some handouts over here that I'd love to show some people. Maybe if you're interested, you can find me. I'll have them. But I've got some documentation, process documentation from Kelly Green Biofuels and Midlands Biofuels that is based on real plants, and it takes training to the next level. It takes process reliability to the next level. It takes quality control to a level of formality that I think is valuable for a process to reliably be bringing in a profitable stream. I would like to thank some of these resources that I've drawn a lot of experience and interest and good conversations with, and these are folks that have been in my circle that are all hard at work at this, figuring this out. How does this work? What's the business model, the process model, or what are the options that work for us? And of course, the CBC organizers and contributors. Thank you, Dara. I'm glad this is happening this year, and it's happening here. I'm glad that you did this work.
Thank you, guys.
Doris and everybody
Thank
else.
you. Really.
So I don't know that we have a lot of time for questions and comments now, but I'm happy to talk process with anybody throughout the weekend. And if there's anything that doesn't seem resolved, let's talk about it. I'm around. Thank you.